everyone and welcome to ITLS Academy Empower the Youth. So today in this lecture we will going to start with a new analytical technique, or you can say method, that is potentiometric. So potentiometric is a broad topic of analytical techniques in which we will going to see the working principle, we will going to understand its instrumentation part, and the most important part, that is the application and how the working of potentiometry take place. So now let us understand what is actually potentiometry is. So potentiometric is based on zero current measurement, means it is static measurement. So there is no zero. So you can also say that since it is based on zero current measurement, so it is known as static technique. It used to obtain, and basically it is used where you want to obtain the information of how of the composition of an analyte, means what is the composition of analyte. So to obtain that information, this potentiometry is used. Then it is the potential between two electrode is measured. So by the help of potentiometry method, you can measure the potential between the two electrode. So this is the overview of potentiometry. So basically potentiometry is nothing but it is based on zero current measurement, that is known as static measurement. It basically used to derive or detect the information of the composition of an analyte. Then it is used the potential, it is used to measure the potential difference, potential between the two electrode. So this is whole the overview. So depending on upon this slide, we will going to understand further. Now let's see the definition part of potentiometry. Okay, so potentiometry, since the name suggests potentio and metry means method, so it is an electrochemical method, means here electrical as well as chemical method are basically coupled together, and it is used to measure the electrical potential that we have discussed in the previous slide. Potential difference between the two electrode, those electrode which are immersed in the solution to be analyzed. Okay, so basically in simple language, if I tell you about potentiometry, so potentiometry, it is an electrochemical method. It is one of the most important analytical technique where you measure the potential, electrical potential difference, not difference, potential between the two electrodes, those two electrodes which are immersed in the solution. Okay, now the second point says the necessary equipment for the potentiometry consists of a potential measurement instrument. Okay, since the name suggests potentiometry, so if you see the necessary equipment to carry out this potentiometry method, so you need to have a potential measurement instrument. Which type of instrument? Potential measurement instrument. So this is an instrument which have a reference electrode and it has a indication electrode. So basically potential measurement instrument, it consists of two types of electrode. This is again very important, because in examination or in the interview point of view, this question may arises that what do you understand by potential measurement instrument, means potential measurement instrument kya hota hai. So it consists of the one reference electrode as well as one indication electrode. So the techniques known as potentiometric method, it evaluates the electrical potential difference that we have discussed in the point first. So potentiometer, it is a it has a indicator electrode, it has a reference electrode, and it have a electrolyte solution where the electrodes are immersed. Okay, and basically it also contains the ions. These ion is used to perform the potentiometric measurement. So Why ions are required? Just to measure the potentiometric measurement. Okay, now let's see what is the instrumentation of potentiometry is all about. So if you see this diagram, so this is a potentiometry meter setup. It has a indicator electrode, it have a reference electrode, and it has a salt bridge, and these are the solution, and where the electrodes are, you know, immersed in it. Okay, so this is the thing that we have discussed here. Now let's move further and let's see the intro further. So again, what is the principle of potentiometry? So potentiometry principle, it involves in the potential, the principle that is involved in the potentiometry is, so when the pair of electrode, which type of electrode, one the reference electrode and the one the indicating electrode, when these electrode they are placed in the sample solution, so it shows a potential difference. So when these two electrodes, reference electrode and the indicator electrode, so as you can see, these both the electrode are placed in the solution, and this is a electrolyte solution. Okay, so when they both are placed in the electrolyte solution, so both of them, it shows the potential difference. Okay, how they are showing the potential difference? When you add the titrant into the solution, or when you change the concentration of ions, because ions here, I have told you that ions are needed to perform the potentiometric measurement. So how these two electrode will show the potential difference? When you add the titrant or when you change the concentration of the ions. Now generally the question arises that what are reference electrode and what are indicator electrode? So the reference electrode, the part of the cell that is held constant, means the part of the cell that is constant, that is not moving, that is static at one place, is known as reference electrode. Whereas the indicating electrode is the part of the cell that contains the solution. Okay, so this part of the cell, it contains the solution that you want to measure, or you can say it consists of a solution of your interest to be measured. Okay, so this is the basic principle behind potentiometry. So potentiometry, the principle which is involved in potentiometry is when the pair of the electrode, that is reference electrode and indicating electrode, they are placed in the sample solution, it shows the potential difference. Okay, so how they shows the potential difference? By the addition of titrant or by change in the concentration of ions. Okay, now let's move further and let's see more about the principle. So the reference electrode is the electrode. So again, I have already told you what is reference electrode. Now let's see the definition of reference electrode, because in examination they can ask you what do you understand by reference electrode. So the reference electrode is the cathode electrode which contain it of its own potential value. Means this electrode that is present this side, the yellow one, so this type of electrode is the electrode which contain its own potential value. And it is stable, means it is constant, it is static at one place. Okay, so whenever it is dipped in a sample, means electrolyte sample, it has its own potential value, and the other thing is that it is stable. Okay, now the salt bridge which is used to prevent the interference of analyte solution with that of reference solution. Okay, now here the analyte solution, means the analyte solution which is used, it is the solution whose potential is to be measured, or you can say analyte solution is those solution of interest that you want to measure. So the first we have discussed the reference electrode. Now let us understand what is indicator electrode. So have told you earlier also that indicator electrodes are the part of the cell that contains the solution. Okay, so this type of electrode is the electrode which responds to the change in potential of analyte solution. So whenever there is a change in the analyte solution, means whenever there is a change in the potential of the analyte solution, so this indicator electrode respond to that particular change. Okay, so the electromotive force of the complete cell is given by the following equation. So there is an equation where the electromotive force that is applied to the cell, so it is given by the following equation, this equation. Okay, so this equation, so what is this equation? E cell is equal to E reference plus E indicator plus E junction. So whereas the E reference, so this one, this part, so this is the electromotive forces of the reference electrode. E reference is the electromotive forces of the reference electrode, whereas E indicator is the electromotive forces of the indicator electrode. So the first reference refers to the reference electrode, electromotive forces of reference electrode, whereas E indicator, it refers to the electromotive forces of indicator electrode. Now what is E junction? This is the new term to understand. So E junction, it is the electromotive forces at which at the junction of the liquid. Okay, so this is the equation. You have to understood that the electromotive force of the complete cell is given by this equation. Now let's move further and let's see the type of potentiometry. So basically potentiometry is of two types, the direct potentiometry and the standard addition potentiometry. So as you see this direct potentiometry, so the direct potentiometry is nothing but it is a measurement of electrode potential directly, from which the concentration of active ion can be determined. Since the name suggests direct, so here the measurement of electrode potential is measured directly. Okay, and from where this measurement is taking place, from which the concentration of active ion can be determined. So direct potentiometry measurement offers a very quick and practical way to assess the activity of various cations and anions. Okay, so here the comparison between the potential that an indicator electrode develops in the cell while immersed in an analyte solution. So the simple term में the type of potentiometry is basically of two type, direct and indirect. The direct is the measurement of electrode potential directly from the concentration of active ions that could be determined, whereas the standard addition method, it is a additional approach that entitles by comparing the electrode systems potential. So where you do the comparison of electrode system potential, so there the standard addition method is used before and after the known amount of analyte solution. So basically in this the direct measurement is done, and in standard addition method mein the comparison of electrode potential is performed or is done how before and after the amount of analyte solution is added to the volume of the standard. So this is the direct and standard method. Now, as we have already discussed the types of electrode that are used in potentiometry, so as you see, this is an indicator and reference electrode. So now we will going to understand the indicator electrode in detail. Okay. So if you see the indicator electrodes, so the ideal indicator electrode should react quickly to the changes in the ion concentration as well as when the ions present in the sample matrix are present. So basically, if you see the indicator one, this this type of electrode. So since we have already discussed that it is a static and this type of indicator at, electrode, it is a perfect in means it is it this type you can say that this is the ideal indicator electrode, which means if you see the indicator electrode, so the ideal one should react quickly to the changes in the ion concentration. So whenever there is a change in the ion concentration, so this indicator electrode should indicate that particular change. Since the name suggests indicator, indicate that changes and that occurs in the concentration of the ion, as well as when the ions present in the sample matrix. Okay, so any change is there in the concentration as well as in the sample, so this type of indicator electrode could detect that change. So a perfect indicator, if you see a perfect or an ideal indicator electrode, it is a selective and repeatable. Means those type of indicator is selective and it is repeatable, and it functions for a longer period of time. You can say it have a long period of time. And the ion selective electrode, it is since it is performing its work very well, so it is a very effective indicator that is used in the electrode potentiometry. Now again, there are mainly two types of indicator electrode. So the first one is your metallic indicator. So if you see the metallic indicator, so metallic indicator, so these type of electrode, it develops the you can simply say that it simply transmit the electrons to or from the reactive species in the solution, and it work best when the surface is large and clean. So metallic indicators, again these type of indicators all it develop the electric potential in response to the redox reaction on the metal surface, and it is simply transmit the electron or to or from the reactive species that are present in the solution, and it works best when the surface is clean. So if you say the examples, so there are different types of in indicator electrodes. So for example, zinc, copper, okay, mercury, etc. Now let us discuss the general method of potentiometry. So how this potentiometry method or working take place? So this is the device, as you can see, this is the whole setup. So you have to switch on the instrument. After switching on the instrument, means after you get start with the instrument, so you have to connect the standard calomel electron to the positive terminal, or you can say the socket, and the glass electrode to the negative one. So the calomel electrode is connected to the positive terminal or socket, you can say, and the glass electrode, they are connected to the negative one. Then you have to arrange the calomel electrode and the paddle of the stirrer in such a way that it must be at the lower level of the glass. Means the glass electrode, as you can see, it should be at the higher level as compared to the calomel electrode. So you have to adjust the meter to 0. You have to check whether the meter means what is the reading of the meter at the time you have switched on the instrument. So the meter reading should be at 20, and the electrode system should be standardized as a subsequent readings are to be taken with the stirrer motor running. Now after that is, as you can see that after the whole setup is done, as you can see in this particular diagram, the one beaker is also attached. So you have to rinse the beaker and properly with the water and the electrode. After rinsing the beaker and the electrode thoroughly with water, then you have to then with the solution to be titrated and placed in the volume in the beaker, as you can see this one. So after washing the electrode and beaker, you have to fill this beaker with the solution that to be titrated. As you can see, this is the whole setup for the titration. Okay, so you have to fill the beaker with a solution up to a measured volume, and then you have to add sufficient water to cover the bulb of the glass electrode adequately. Means the water should be of sufficient quantity. Why? Because you have to cover the bulb of the glass electrode. Okay, now you have to, again you have to switch on the stirrer and measure the pH of the solution. So after that, there is a switch, you have to switch on the stirrer, and this is a stirrer. And after that, as you can see the black one, and you have to note down the pH of the solution. Then after that, you have to add 2 ml of titrant. Okay, so the process that you perform for the titration, so here it is done in the same way, that you add 2 ml of the titrant. Okay, after adding the 2 ml of titrant, allow the sufficient time to mix, and you measure the pH of the solution. After that, measure the pH of the solution, then you add further quantities of titrant. And after adding the sufficient quantity of titrant, as the endpoint is approached, you have to reduce to 0.1 ml increment and measure the corresponding values. The same thing that you do in titration process, you have to perform it here also. Then after you obtain the readings of the pH for about 5 ml beyond the equivalence point, now you have to switch the meter to standby and turn off this stirrer. Wash the beaker and electrode thoroughly with the distilled water. Now since your pH value reaches to the 5 ml, that is beyond the equivalence point, then after reaching the equivalence point, or after reaching beyond the equivalence point, you have to switch off the meter and your this meter to a standby, and then you have to turn the stirrer. After turning off the stirrer, you further wash the beaker and electrodes thoroughly with the distilled water. Now with the help of the graph, you plot the pH versus the titrant. Means one side should be the pH value and one side should be the titrant that is added. Then you read off the equivalence point from the graphs. After that, you calculate the data from this value, means that the values that you have plotted in on the graph. So the graph should be between the pH value versus the titrant. Okay, now you have to calculate the values, that pKa value of the acid from this. So this type of values that you have plotted, and the calculation is known as Hardison equation, which is valid only for the range that is pH 4 to pH 10. So this is very important, that Hardison equation is only valid for the pH that is between 4 to 10. Okay, so this is with the working of potentiometry. It means how potentiometry basically works. Now let us discuss some important application, students. So if you see the application part, so potentiometry is basically you can say have a huge application in clinical chemistry, in environmental chemistry, in potentiometry, trick titration, in agriculture, in detergent manufacturing. So you can see that in every field it is using, even in the food industries, in the pharma industries. So now let us understand how it is be useful in the clinical chemistry. So whenever you want to have a to select the selection, means if whenever you want to have ion selective electrode which are present, the sensors that are used for the clinical sample. Okay, so there this type of application is widely used. So the most common analytes are analytes such as sodium, potassium, calcium, hydrogen, chlorine, which are dissolved gases such as, and even the dissolved gases such as CO2. Okay, now environmental chemistry, if you want to analyze different types of nitrogen and iron, okay, that are present in water. Ammonia means whenever it is present in water and the wastewater. Then whenever in potentiometric titration, where you want to determine the equivalence point of an acid base titration that we have just discussed here, so there also potentiometric is used. It is also possible for redox reaction, for the precipitation acid base complexes, as well as for all the titration that is there in aqueous and a non aqueous solvent. Then it has a huge application in the agriculture. Okay, so whenever you want to determine means what are the different like if, means what are the different and calcium or potassium or chlorine that is present in the soil or in the plant material, feed stuff, fertilizer. So in this also, this this potentiometric is widely used. Then if you want to have the detergent manufacturing, means in detergent manufacturing also it has a huge application. Now comes the most important. So this is the automated potentiometric device, as you can see. So how it is used in food processing. So different types of compounds that are present in the food, or so in that particular process, in that particular uh, thing, potentiometry is used to check the presence of any assay of bisa- bisacodyl suppositories, and assays of sulfa drugs can be estimated potentially. And even if you want to nitrogen oxide and means in meat preservatives, means in different food there are things that are present. So in that particular sectors also food processing, this potentiometric is good. If see, calcium is there in a dairy products, in beer, so you need to know the presence of different compounds. This potentiometric is used. The simple example is when you want to know the salt content of meat, fish, or dairy product, like juices, fruit juices, brewing solution, then also this potentiometer is used. So now comes the advantages. So advantages play a very important role in every analytical technique. From this we can understood why this particular lecture technique is having the advantages. Means what are the different, मेरा कहने का मतलब ये है कि how these particular analytical techniques are widely used. Means why, what are the different advantages. So it is relatively inexpensive, means there is no higher cost, and it is very simple to use, means you don't require any additional training to operate this, and it has a very wide range of application that we have already covered, and it is and it can used a wide range of concentration also. So under the most favorable conditions also, this technique is used where you want to measure the ions in a relatively dilute aqueous solution, and it is a very rapid and easy method. Okay, so they are unaffected by the sample color of or turbidity, and since these are the advantages, so now let us understand the limitation or disadvantages. So we all know that electrodes are fragile, so they have a very limited shelf life, so they can interference can be done by other ions also. then electrodes, they can be affected by proteins or other organic solutes. So here also the main drawback is the electrodes. Why? Because electrodes are fragile. Since the electrodes are fragile, so they have a limited shelf life. They can be affected by different types of organic solutes, and they can be affected by proteins, and their precision is really better than 1%. So these all are certain limitations that are associated with this technique. So that brings to the end of the lecture. I hope you have understood the lecture. If you have any doubt, any queries related to the lecture, you can simply leave your queries in the comment section below. In the next lecture, I will be answering the queries. Thank you for watching. Please do like, share and subscribe. Thank you.